my name's Rose. I'm another developer on the DAFNI team. And before I get into the demo, I just want to say I'm using the non-admin one account as well. So I've just got regular user permissions. I don't have anything special on my account either. And as a result, you can see in the bottom right-hand corner of this catalog here that I've only got access to 17 models currently. But that's not the total number of models on the DAFNI system. We've got many, many more. They just haven't been shared with this user or with the public catalog yet because they're currently in development and currently being worked on. So I just want to highlight some of the models that we do actually have on DAFNI available on DAFNI at the moment. So we've got the NISMOD models. NISMOD's been mentioned many times, and I've actually shared those with this user because I'm going to show off a workflow with these models later on in my demo. So you can see them listed down here. I've got an energy demand model, energy supply, a transport model, the energy transport model that links the energy models and the transport models together, and then a couple of adapter models that just link all of the other models in together as well. We also have a transport digital twin model from Sheffield, a sort of a proof of concept that digital twins can be hosted on DAFNI. We've also got an urban development model, which is a grid cell based model that explores future urban development, and that is used for producing some of the base data sets that NISMOD 2 uses, and it's also used as a sort of first step in the various different models from the OpenClim project, and we actually have some of the models from that OpenClim project already on DAFNI as well. So we've got the CityCat model and the flood impact models. Those are both on DAFNI at the moment and are actively being developed with new versions of models being uploaded all the time to DAFNI as well. And then we're going to get some of the other models from the OpenClim project onto the platform as well, like heat stress and other models like that. So to start with on the model catalog, I'll just mention that you can, as a user, if you go away and create your own account, you'll immediately be able to add your own model by clicking on that Add Model button. You can see on the left-hand side of this page a list of steps just to make sure that your model is ready to be uploaded on DAFNI. This takes you away to a documentation site, so you can just make sure that you're writing the model definition file, which I'll cover in a second, correctly, and also to make sure that you're containerizing your image file correctly. I'll cover that as well in a second. If you prefer videos, we also do have demos and tutorials on our YouTube channel that cover this process. I'm going to be just quickly uploading the COVID sim model, which is a model from Imperial College London, and it's a spatial model that models the transmission of COVID-19. So let me just grab these files and just have to confirm that I've completed all the steps because I have earlier, and I can track them on. And then I'll set that uploading and just quickly cover the two different file types. Oh, interesting. Okay, well, I've already got one uploaded. First time I've seen that happen in a while. So that would have uploaded a file or a model very similar to this, in fact, identical to this. You can see on the left-hand side a load of metadata. So this is the first thing that the model definition file is used for. It's used to add a load of metadata that explains to users what the model is about. I give a good description, hopefully. You can also link back to the source code of your model. So if you've got a GitHub page that you want to link the users to, then you can link that in the source code field here. Also, the model definition file is used to tell the system various different things about your model. So you've got a list of input parameters and then metadata around those telling the users what type the input parameter expects, descriptions that you can hover over there and see a description of the various different parameters, and some default values just to provide users with a hint with the kind of values that you're looking for, as well as min-max map values for numeric parameters. Then the next thing is a list of data sets that you want to provide, so paths that they can be expected to be found in the container file when the model runs on DAFNI, and the default data sets that you can provide to that. But users can go away and at runtime when they create a workflow, they can change the data set that the model runs with. And then finally, a list of output files that your model produces. And again, that's just so that users can see that list of output files. And if they want to build a model that builds off what your model is doing, then they can just have a look there and see what actually your model will produce, so they know what they're going to be building off of. And the other file that I tried to upload there, is a containerized image file. So this is just a compressed version of your model file that's wrapped in such a way that allows us to run it without an issue. So we can be completely agnostic about any languages, tools, or software that you use to create your model. We really don't care about that. As long as it's containerized using Docker, then we can just run it and with no issues. So yes, as Alex said earlier, we also have versioning for models too. So if you click the View All button there, you can see the list of versions. This model clearly only has one version, but if you press the Edit button in the top right-hand corner here, and then add a new either definition file or image file, then you can create a new version of that model. I'm just going to go back to the page, and it will appear in that dialog box up there. And so the extra thing to add a little bit of description of these versions naturally in the model catalog that models have that datasets don't have is these flags that you can see here. So we have a latest flag, a default flag, and a deprecated flag that you can assign to your various model versions. The latest flag is an automatic flag that gets passed from one version to the next as you upload newer and newer versions of your model. And that just signals to users that this is the absolute most recent version of the model. You can also make a version default by pressing this button here, and that overrides the latest value and basically tells users this is the version of your model to use. Don't go to the latest version. Don't use any of the other versions if you're not sure what you're doing. Just use this model. And then you can also deprecate versions of your model if the model has a bug or something like that, and you just don't want users to use it anymore. You can signal that with deprecation. Or if you just want to remove it from the platform, there's a delete model button down in the bottom left-hand corner there. But we do prefer you deprecate rather than delete models. And I just want to quickly say that the power of modeling on DAFNI does allow us to actually run this COVID model. So if I tried to run this model on my local PC, I'd only be able to run for New Zealand because the RAM requirements of this model are so high. So actually to run the UK, the model for the UK, it requires about 100 gigabytes of RAM, which I don't have in my work laptop. I'm not sure many people do, but we can make that available to you on DAFNI. So that's the modeling system. I'm just going to switch over to the workflow system now. So workflows are how we enable users to run their models. You can create a fresh new workflow by pressing that button in the top right-hand corner there, but I'm not going to because that takes a little bit of time that we don't have right now. So I'm just going to click on one that I've made earlier. This is the metadata page. You can fill all this metadata in, and we are preparing and adding to this metadata right now. And then you click through and go into edit and you actually see a visual representation of your workflow. So if you just look at the key in the top right hand corner, this lists the different types of steps that workflows create. So the simplest is the model step in green there. That allows you to run your model. It allows you to list the parameters and the values that you want to send to that model, and also the data sets that you want to use as well for that model run. And then once you've done that, that model step just runs the model. It doesn't do anything with the data that comes out of that model. So if you actually want to publish or visualize that data, you need to use one of the other step types. So the publisher you point it at model step and it'll take the results of that model out, and then it will upload that to our NID catalog in private. So you'll still be the only person that will see that. And then the visualization step will upload to the catalog, and also it'll create a visualization, and that will be either a Jupyter Notebook visualization or a drag and drop visualization, depending on which you choose. And then finally, we've got the iterator type, which allows you to select a model and then iterate over some of the parameter values with many different values. And we're actually, again, one of the features that is in active development is expanding that iterator. Currently, you can just create a Monte Carlo iteration with a load of random values to send to parameter values, but we're massively expanding that functionality as I speak. So yeah, I'll just quickly click on the model step, and you'll be able to see that I've got the COVID sim model selected here. The parameters, as I mentioned, with their default values, I'm not going to change those. And then the data sets that I want to use to this model. So if I wanted to change these data sets, I press this edit button here, and then the data set catalog will load. My internet's being a little bit slow, but then the data set catalog does load. And if I want to select one of these data sets to use, I press select and I'll confirm it, but I don't want to do that because I'm not sure what's in those data sets and it won't work. But you can just select it, and then if you do make a mistake, end up making a mistake, you can remove data sets. But if you just want to get back to whatever the model developer said is safe to use with this this model, you can press the use default buttons there to get back to that. Then there's the publish step. So as you can see, the same metadata form needs to be filled out as does for uploading your own data set, with a couple of exceptions. The date created is set by whenever you run the workflow. The organization is by default set to DAFNI workflows, and then the organization name is set to a value that makes it easier to get back to this in the future, and I'll show that off in a second. And then you point it to a step to take the data files from, so this is saying the model step. And then it's also points to the path. So you can see there it's got some stars, some wildcards in there, and that's just a little cheat way to say get all of the files and folders under that outputs folder. And then one thing I just wanted to do and show off was I can create a visualization step for myself. So if I just create a visualize, so we just name the step, and then I create set a name for the actual visualization itself. And then a description, I'll just copy and paste that. And then you can see the types. So I'm just going to select this to drag and drop. Unfortunately, the COVID model runs for about an hour, so we won't be able to show this, but Tom will be showing off the drag and drop tool. And then I want to use some metadata, and we actually have it so that the publish step metadata is copied across here into this visualization step, just for speed. So again, you point it to the step that you want to take the data from, and you set the file. So again, I'm just going to use that wildcard because I wanted to grab all of the files there. You create the step, and then you create the workflow. I've got a new version of that workflow uploaded to DAFNI and ready to run. So I could press execute, and that would go away and run. But as I say, it'll take an hour to run. So I can click on a version of the workflow that I created earlier that's finished, and you can see little icons here that show off the status of the steps. So these are all ticks because it all worked successfully, but we've got exclamation marks if it fails, or pending and running icons if you're checking on the status as you go. And again, you can click on these and see summaries of the information that's been passed to this, so you can see all the parameter values and the data sets, the metadata that's been sent across. And then if you click here, that'll take you back to the visualizations page. Tom's going to be showing that off, so I won't show that off right now. And as I said, this uploads a data set, so you can see here several uploads from the workflows, from that particular workflow, because I've run it a few times. And you can see all the same files that were listed in the model definition earlier. And then, as I mentioned, the creator field here, if you click on this link, it'll take you back to the specific instance within the platform that actually created that data set. And then in the future, we're also going to have a link here to take you back to the workflow itself, just in case you want to make any changes after you're inspecting the data, after it runs. And so just as a last point, I just wanted to show off what I think is one of the most powerful parts of DAFNI and the DAFNI workflow system in particular, is that workflows allow you to really easily chain together several models in one workflow and run them. So this is a version of a NISMod workflow that I have used before. And so you can see there's 5 model steps there, all running into the next. So it starts off with a decision step, which I will be able to explain if you all knew a bit more about NISMod 2, but it's just a step that sets up all the rest of the steps. That's essentially all it does. Then it runs the energy demand model you can see here for a 2015 time step, and it takes all of the data that comes out of the decision step. You can see we're using this field here, and then it runs some adapters which convert some of the files from the energy demand model into files that the transport model understands. And you can see again, it's taking energy data from the energy step here. Again, it runs a transport model with the data from the adapters. Then it runs the energy transport module, which collects all of that data into something that we want to publish. Again, it passes on the data, and then we publish all the data at the end. So yeah, that's what I think is the most powerful thing of the NISMod system, or the workflow system allows you to run NISMod. And now I'll be passing over to Tom for a demo of the visualization service.